Greetings and welcome to Totality Town. There are lots of things that make total solar eclipses amazing events, but the corona is at the top of the list. When the moon completely covers the sun's disk, it's an awe inspiring sight. The sun's blazing brightness vanishes, and instead, you see what looks like this black hole in the sky with these ghostly white tendrils extending out from it. It's amazing. So make sure you get into the path of totality on April 8th. What exactly are we seeing when we look at the corona, and why is this sight so rare? Let's get into it. The corona starts just above the sun's surface, and it extends 8 million kilometers out into space. Now, for comparison, the sun's radius is just under 700,000 kilometers. Compare that to 8 million, and yet the only time you'll ever get to see the corona for yourself is during the total phase of a total solar eclipse. For all human history, the only time anyone could observe the corona at all was during a total solar eclipse. That changed a little bit in 1930 when the coronagraph was invented. A coronagraph is a device that blocks the sun's disk so instruments can image and measure the corona. You can learn more about those instruments in the video linked at the end of this episode. The bottom line, though, is that coronagraphs still don't let us see the part of the corona closest to the sun's surface. We can see the outer corona, but those innermost 800,000 kilometers, half a million miles above the sun's surface, that's still only possible during a total solar eclipse, which is why astronomers still get so excited about them. The corona is the outermost layer of the sun's atmosphere, just above where we see prominences, like we've talked about in previous videos. One of the great mysteries in solar physics is why the corona is so hot. You'd expect the temperature of the ionized gases to be hottest right there near the sun's surface and then cool down as you move out into space, but that's not what we see happening. Go out about 1,000 miles, and the temperature skyrockets from 10,000 degrees to roughly 2 million degrees. Yeah, you heard that right. 2 million degrees. Astronomers first measured this temperature back in 1939, which absolutely blew everyone's mind. Ever since then, astronomers have been trying to figure out what's causing such an astounding temperature jump. There are hopes that the newly operational Daniel K. Inouye Solar Telescope and the Parker Solar Probe, which is actually going to fly through the corona, will be able to solve that mystery. So, if the corona is so incredibly large and so insanely hot, why can't we see it? Answer: because it's just so thin and wispy. The density of the material in the corona is about 10 trillion times less dense than the air we're breathing here on the Earth's surface. That's why the corona is about a million times dimmer than the light coming from the surface of the sun. Under normal conditions, the corona simply gets lost in the dazzling glare coming off of the rest of the sun. When you look at the corona during a total solar eclipse, notice that there are these big streamers of materials extending way out from the sun's surface. During the quiet periods of the sunspot cycle, these large structures are usually found only near the solar equator, and that was the case back in 2017. These solar streamers are spectacular, but 2024 should be even better because we're expected to reach the most active part of the sunspot cycle late in 2024. The increase in solar activity means that structures in the corona might be visible anywhere along the edge of the sun and not just limited to the equator, as you can see in this beautiful NASA astrophoto of the day by Mr. Eclipse, Fred Espenak. This image is of the April 20th, 2023 total solar eclipse down in Australia, and there are coronal streamers just all over the place. 2017 total solar eclipse was the first time astronomers were ever able to predict the shape of the solar corona. The mathematical predictions were an impressive match to what observers actually saw. However, the sun is incredibly dynamic, and you can only make these kinds of predictions about a week ahead of time. So expect predictions like that for the April 8th total solar eclipse to be in the news around the first few days of April. I mean, it makes sense. You can only predict the weather on Earth a little more than a week ahead of time. Why should space weather be any different? I probably won't have time to do a new video on those predictions when they're released, but I will make a post about it in the channel's community forum. So please subscribe to the channel and allow notifications so you don't miss it. Thank you for joining me for this episode. Hope to see you again next time here on Totality Town.